Now we have looked at the magnet and its usage, and now it is very important to know the characteristics of a magnet. So what are the characteristics of a magnet? So first thing you should understand is it able to attract magnetic materials from a distance. That is a basic characteristic of magnet. And magnet has two poles. The first is the north and south. As you can see here, they have something called the N. Here you have something called the S. N north, S south. Okay. Now these two poles have the strongest magnetism. Again, magnetism is basically something that help to attract lah. Okay, on the magnet, allowing to exert the strongest force of attraction and expulsion. Now, it's important to understand the word attraction and expulsion. Attraction means that it comes closer, and expulsion basically it pushes away. Okay, so let's look at attraction. So attraction can happen when there is something called the unlike poles. What do you mean by unlike poles? Means that one side is north pole, another side is south pole. Again, north pole one side, another side is south pole. That's called unlike poles. When it is unlike poles, it attract one another when it facing each other. It facing each other. Again, it only attract one another when they are facing each other. Okay, the keyword here is attract and facing each other. Okay. Now on the other side, there's expulsion, and expulsion happens when there is something called the light poles. Light poles basically means they are the same, right? Okay. So example, if there's two north pole, as you can see, that it will actually happens expulsion. They'll push away each other. And again, the same thing when there's two light poles like south, again they will push away each other. It means that they will not be attracted to each other. Okay, it will repel. Again, the word here is repel or push away one another when it's facing each other. Again, the keyword here is repel when they face each other. So it's something that's important to know. North south attract to each other. North they repel. South they repel each other. Okay. And with that in mind, there's another something called the freely suspended bar magnets. So is there anything special? Not really lah. Okay, basically there's a bar magnet. If you hang it there, we call it as freely suspended bar magnet. And what happened to this magnet is that it will actually, if you hang it there lah, okay, it will like turn, right? It will automatically come to rest pointing at the north-south direction. Means that if I have a retort stand, I hang this magnet here, then you see that the north side of the magnet just stop here. That basically is the north. That is basically the north. Means that we know the compass, right? Compass works the same way, but this one is just hang it. You will just point at it easily. And because this pole is pointing at north, that's why we call it as the north-seeking pole. And this place is pointing at the south. That means that is south. And that's why this is called the south-seeking pole. Okay? So that is something that's kind of important to know. So there's something called the freely suspended bar magnets. And the key thing is it will come to rest pointing in the north-south direction. And this freely suspended magnet sometimes also being done in kind of something experiment like this. They will put the same thing, the retort stand here, they will put the freely suspended magnet here, but they will put in something called the magnetic material or non-magnetic materials. And what is special about this is when they put in non-magnetic magnetic material, as you can see here, the paper clip will not be attracted to go up. But if the put in the non-magnetic material, it will be attracted. Why? Because this magnetic material is attracted by the magnet. Now, what if I draw another retort stand, the magnet? I don't put anything here. Will it be attracted? Yes, it will be attracted just like this one. Then what actually causes that it will not be attracted, that it will fall? It is because there is something called the magnetic material, and this magnetism, which is a kind of the force of attraction or repulsion, cannot pass through the magnetic materials because this actually block it. This already connected, kind of like attract to each other already. That's why it cannot attract the paper clip. Whereas non-magnetic materials, it's just there, but it does not affect anything. Okay, that's why magnetism can pass through the non-magnetic materials, and it can attract the paper clip, causing it to stay afloat. It works the same way if I don't have anything here. Okay, because it does not affect anything, and that is basically the magnetism's kind of ideas here. Okay, so I hope you learned something, and thank you. See you. Bye bye.